Imagine for a second, right, that you are running a massive fleet of delivery vans.
Okay, stressful already.
Right. And today is May 29, 2026. Your entire business, I mean, your profit margins, customer satisfaction, it all relies completely on those vehicles just constantly moving.
Mhm.
But suddenly, the very act of fueling them up has morphed into your biggest financial and logistical nightmare.
Yeah, because the vehicles themselves are incredibly advanced at this point. I mean, the real liability has become the tether to the energy source itself.
Exactly.
The physical infrastructure required to keep a fleet moving is just dragging the entire logistical chain down.
And we are seeing that breaking point across the board today, which honestly makes this the perfect time to look at the stack of sources we've gathered for you.
It's a great stack today.
It really is. We're pulling insights from a historical 2012 California fuel cell partnership roadmap.
Which is fascinating, by the way.
So fascinating. And we're comparing that against modern fleet data from GM, plus analyzing some really cutting-edge briefings from ESFIL, ADS Tech Energy, Beam Global, and Renewable Innovations.
Yeah, and looking at these documents side by side, it reveals this massive disruption that's just happening right under our noses. The constraints of our energy grid are literally forcing a complete rethinking of commercial mobility.
Absolutely. So our mission for this deep dive is to explore how the very concept of the gas station is being radically reimagined.
Right.
We are actively shifting from a world where vehicles have to travel to the fuel to a world where the fuel comes to the vehicles, and we're completely bypassing some massive multi-billion-dollar grid limitations along the way.
It's a total paradigm shift.
It really is. Okay, let's unpack this.
Well, to really grasp the magnitude of the 2026 charging crisis, I think looking backward provides the perfect context.
Yeah, for sure.
Because before we can appreciate the wild mobile energy solutions happening now, we kind of have to understand the foundational logic.
And the agony.
Oh, the absolute agony. Yeah, the agony of building a fueling network entirely from scratch.
And that 2012 California Fuel Cell Partnership Roadmap, it is basically a masterclass in that agony.
Definitely.
Back then, California was trying to launch early commercial fuel cell electric vehicles, or FCEVs, and the technology was actually stellar for the era, like offering 250 to 400 miles of range.
Which was huge back then.
Right. And a refill time of under 5 minutes. But they ran into the ultimate infrastructure paradox.
That classic chicken and egg.
Exactly.
Because no consumer is going to buy a vehicle if they can't reliably fuel it, right?
Right.
And on the flip side, no energy provider will spend millions building a fuel station if there are literally no vehicles on the road to use it.
It's just a terrifying standoff for early adopters.
It really is. So the state had to calculate the absolute minimum viable infrastructure required to just break that stalemate.
And their modeling suggested that they needed 68 strategically placed stations by 2016 just to support anywhere from 10,000 to 30,000 vehicles. Yeah. And constructing a new energy network from scratch is just brutal on the balance sheet.
Oh, yeah.
The roadmap projected it would cost between $65 and $67 million in funding just to bridge the gap before those early stations could become self-sustaining or, actually profitable.
Right, because in those initial years, a heavily subsidized station might see, maybe a handful of cars a day?
Exactly.
So to figure out where to place these incredibly expensive, highly risky assets, the National Fuel Cell Research Center deployed this spatial and temporal modeling system.
The street model, right?
Yes, the street model. And they divided the map into 3 vital categories. First, you had clusters, which targeted high-density early adopter neighborhoods.
Makes sense.
Then connectors, which served as the highway arteries linking cities so drivers weren't just trapped in their local zip codes. And finally, destinations.
So they decided to concentrate 45 of those initial stations within the clusters. And that clustering actually birthed the golden rule for their entire project.
The geometry of it all.
Yeah. They mapped the geometry so that a driver would have a maximum travel time of just 6 minutes to reach a hydrogen pump.
Yep, that 6-minute rule was the literal linchpin. The entire multi-million-dollar strategy hinged on that specific travel time.
Okay, but wait, 6 minutes. I have to push back on the math there.
Go for it.
Did they really think placing hydrogen at just 5 to 7% of existing gas stations within a cluster would be enough to give a consumer actual confidence?
It sounds super low, I know.
Right. I mean, 5% is practically a rounding error compared to the ubiquitous corner gas stations we were all used to.
What's fascinating here is the psychology behind the infrastructure.
Oh, interesting.
Yeah, the strategy wasn't actually about convenience. It was entirely about Managing panic.
Managing panic. Okay.
Right. You have to build the exact minimum coverage to create psychological comfort without going bankrupt on unused pumps.
Oh, I see.
So if you know a station is only 6 minutes away, your range anxiety naturally drops to a manageable level.
Nice.
But if you overbuild, the operators go insolvent. And if you underbuild,
The market rejects the vehicle entirely.
exactly.
Man, it was just a geographical tightrope walk. You're drawing these desperate 6-minute circles on a map, sinking tens of millions of dollars into concrete, and just praying the human behavioral math holds up in the real world.
And the fatal flaw of that era really was the total reliance on static, stationary infrastructure.
Right.
You were permanently chained to a physical location, completely dependent on the traffic actually coming to you.
So let's fast forward to the present day, 2026.
Let's do it.
Because that fundamental tether hasn't disappeared at all. It has just mutated into something much, much more problematic.
Yeah, it really is.
The vehicles have evolved beautifully, but the infrastructure bottleneck is just strangling operations.
Because the capabilities of a modern fleet vehicle are staggering compared to those early days. I mean,
Oh, for sure. Take the 2025 Chevy Bright Drop van from the GM fleet data, for example.
great example.
It boasts a 272-mile range, which easily covers a typical daily delivery route with plenty of battery to spare. And the societal pressure to deploy these vehicles is just immense right now. I mean, delivery fleets generate roughly 16% of global CO2 emissions.
16%. That's massive.
It is, with last-mile logistics accounting for half of that chunk. And major urban centers like London and Santa Monica, they are strictly enforcing low-emission zones now.
Right. They're heavily penalizing traditional combustion engines while rolling out the red carpet for zero tailpipe emission vehicles.
Exactly. And beyond the regulatory pressure, the raw spreadsheet economics just heavily favor electrification.
The GM data is so clear on this. It details how the total cost of ownership fundamentally undercuts traditional fleets.
The maintenance numbers are crazy.
Yeah, maintenance on an electric van hovers around, 6 cents a mile, compared to 10 cents for an internal combustion engine.
Right.
When you eliminate spark plugs, timing belts, and oil changes across a fleet of thousands of vans, you're looking at operational savings of under $10,000 annually per vehicle.
Per vehicle. So the vehicles are ready, the profit incentives are clear, but the logistical reality is completely gridlocked.
Yeah.
We are slamming into a modern bottleneck where the electrical grid itself simply cannot absorb the demand.
The ADS Tech Energy Briefing provides a terrifying glimpse into this exact reality.
Oh, the Germany situation?
Yes. The town of Oranienburg in Germany actually ran out of upstream high-voltage grid capacity.
That's just wild to think about.
Literally ran out.
What?
The local utility had to completely halt approvals for new charging infrastructure connections. The main electrical arteries of the city were just maxed out.
So trying to build enough high-speed fleet chargers on our current power grid, it's basically like trying to instantly fill a massive Olympic swimming pool using a standard garden hose.
That is the perfect analogy.
Right. The plumbing simply cannot handle the sudden, massive transfer of volume required to keep dozens of commercial vans moving all at once.
And upgrading that plumbing takes years of bureaucratic permitting and millions in trenching costs alone.
Ugh, the permits.
But interestingly, for fleets that are still running on legacy fuels like diesel, the operational nightmare is just as bad, if not worse.
Oh, the daily friction is unbelievable. The 2026 data from ESFIL highlights that Florida diesel spiked to $5.67 a gallon in May.
Yeah, that's painful.
But the pump price is only a fraction of the actual cost. The hidden drain is the sheer logistical effort of acquiring the fuel.
Right, and this introduces the concept of the deadhead mile, which is absolutely lethal to a delivery fleet's margins.
Yeah, break that down for us.
A deadhead mile is basically when you pay a highly skilled hourly driver to abandon their optimized delivery route, navigate through congested city traffic, find a retail gas station, and then just sit in a queue at the pump.
It is a pure hemorrhage of labor, time, and fuel.
And the inefficiencies compound dramatically once they're actually at the pump.
The convenience store effect.
Exactly. The ESFIL brief heavily emphasizes this. A driver on the clock inevitably spends 20 minutes inside the station buying snacks or using the restroom. Add in the constant risk of fuel card skimming and unauthorized retail spending, and the hidden costs just skyrocket.
Yeah, when you map out the reality of a driver making $30 an hour, wasting 45 minutes a day on fueling logistics, that $10,000 annual EV savings we mentioned earlier,
It completely evaporates.
it really does. Whether you are battling a maxed out electrical grid or paying top dollar for diesel while your driver buys potato chips, relying on a static third-party fueling point has become a massive liability.
The traditional logistical chain is just fundamentally broken at this point.
Yeah.
But our sources reveal a massive industry pivot that's designed to bypass the grid entirely. The first major wave of innovation is this huge shift toward decentralized, self-sustaining charging nodes.
Okay, so if the local utility tells you it will take 3 years to upgrade your depot's power lines, you just generate and store the power yourself.
Exactly.
Let's look at Beam Global's EV ARC. This thing is a 100% renewable, off-grid solar charger engineered to fit perfectly inside a single standard parking space.
The physical footprint is clever, but honestly, the deployment speed is the actual game changer here.
Oh, it deploys in minutes. There is zero trenching into the concrete, zero electrical wiring tying it to a building.
Wow.
You completely bypass the city permitting office, and it generates zero utility bills.
That's nuts.
It's essentially a drop-in fueling station that can reach up to 12 parked vehicles and charge 6 of them simultaneously.
So you are completely severing the bureaucratic delays of traditional construction.
Yes.
And for environments that require massive power quickly, solutions like ADS Tech's Charge Post take a really brilliant alternative approach. It operates as a battery-buffered, ultra-fast charger.
Okay, so how does a buffered system solve the garden hose problem in places where the grid is weak, like that town in Germany?
Right, so it basically acts like a massive energy sponge.
A sponge.
Yeah, it takes a low-power connection from a weak grid drawing anywhere from 22 to 87 kilowatts, which is just a slow, steady trickle. It stores that energy in its internal battery throughout the day and night. Then, when a delivery van pulls up, needing a rapid turnaround, it blasts that stored energy into the vehicle at up to 300 kilowatts.
Wow. To put that 300 kilowatts into perspective for you, that is the difference between a van needing to park overnight to get a full battery versus getting a meaningful route-saving top-up in the 15 minutes it takes the driver to load their next batch of packages.
Exactly.
And here's where it gets really interesting. The charge post has a footprint of less than 2 square meters, but it features 2 massive 75-inch advertising displays on the exterior.
Oh, the ad revenue.
Right. And it can also feed stored power back into the grid for energy trading. So you aren't just bypassing utility upgrades, you are actually monetizing the hardware.
If we connect this to the bigger picture, this technology turns a localized weakness, like a fragile electrical grid, into a literal revenue-generating asset.
It's genius.
Fleet operators are inadvertently creating virtual power plants. They display targeted ads, they hoard cheap electricity overnight, they charge their vans instantly during the day, and they sell their excess stored power back to the city grid during peak demand hours.
They have completely decoupled their operational tempo from the limitations of the local utility.
It's brilliant engineering.
It really is. But even with decentralized solar pods or buffered batteries, the vehicle still has to physically drive to the charger.
Right, the tether is still there.
Which brings us to the final and I think most radical shift in our stack of sources today. If static stations are inefficient and waiting for construction takes too long, why not make the infrastructure itself completely mobile?
You just stop sending the fleet to the energy and you start sending the energy to the fleet.
Yes. According to the ESFIL briefing, the on-demand fuel delivery market has exploded to $6.2 billion here in 2026.
$6.2 billion. That's not a niche market anymore.
Not at all. This is light years beyond like a guy with a pickup truck and a gas can. We're talking about highly sophisticated algorithmic logistics.
The digital integration is really what makes it viable at scale. ESFIL utilizes AI-driven routing to navigate city traffic and dispatch these certified technicians driving high-capacity tankers. And they integrate IoT sensors directly inside the fuel doors of the commercial vehicles.
That part is so cool. The van practically orders its own fuel without any human intervention.
Right.
When the tank hits a specific low-level threshold, the sensor automatically triggers a refill request. The tanker arrives overnight while the fleet is parked, or even directly to an active job site.
And they deliver whatever is needed, right?
Yeah, delivering premium gas, ultra-low sulfur diesel, or renewable diesel.
And we are seeing this exact mobile architecture mirrored in the electric vehicle space, too.
Oh, definitely.
The Charge Fleet article highlights SparkCharge CEO Josh Aviv, who breaks down how mobile app-based EV charging allows fleets to scale their operations instantly.
Which is huge for adoption.
It is. If a company buys 20 new electric vans today, they don't have to wait 18 months for grid upgrades at their depot. They just order the energy to be delivered to their parking lot every single night.
And Renewable Innovations is pushing this concept to an industrial extreme.
Oh, their setups are massive.
They are building massive 53-foot mobile energy command semi-trailers. They offer the MECS, which is essentially a rolling solar array, and the MEC H2EV, which is just packed with hydrogen fuel cells and lithium-ion batteries.
They act like massive traveling server racks for energy.
Exactly. They literally rolled out into the middle of nowhere to power the EVs at Motor Trend's 2023 Performance Vehicle of the Year event.
It just allows massive amounts of energy to be deployed anywhere on the map, totally independent of any existing infrastructure.
Okay. I have to challenge the long-term viability of this, though.
Sure.
Because sending massive, heavy tanker trucks or giant 53-foot battery trailers navigating through crowded city streets just to charge delivery vans, it seems completely backward to me.
I get that.
Aren't we just generating more traffic and more emissions than if those individual vans simply drove to a local corner pump?
It feels incredibly counterintuitive on the surface, I know, but the data reveals a massive logistics flip.
Okay, explain that.
The efficiency comes from extreme consolidation. One high-capacity mobile tanker effectively absorbs and replaces hundreds of individual, highly inefficient trips to a retail pump by those smaller delivery vans.
Okay, wait, let me run that math.
Go ahead.
Instead of 50 delivery vans driving 2 miles off their route, sitting in traffic, idling in a queue, and then driving back, which creates a huge footprint of regional congestion.
Exactly. One single tanker drives a perfectly optimized AI-mapped route to the depot while those 50 vans are literally asleep.
Oh, wow.
It consolidates all those emissions into one highly efficient vehicle. It entirely eliminates the labor waste of 50 different drivers just standing around at a pump.
Right.
And it provides flawless, digitized data tracking for every single drop of fuel or kilowatt of electricity transferred.
Okay, yeah, so the paper receipts vanish.
Completely.
The corporate card fraud disappears. And the 20 minutes of lost time per driver buying chips in the convenience store is just completely erased.
Yes. You are surgically removing all the chaos of the retail environment from your commercial supply chain.
By centralizing the fueling process through a mobile provider, the depot itself basically becomes the gas station without requiring a single permit or a poured concrete foundation.
Precisely.
So what does this all mean?
Well,
If we trace the evolution across all these sources, back in 2012, we were relying on rigid mathematical models, right? Drawing desperate 6-minute geographical circles on a map, just hoping consumers would feel geographically safe enough to buy a hydrogen car.
right. We were building monuments to energy and just hoping traffic would eventually come.
Exactly. Then, as fleets modernized, we hit the brutal realities of a maxed out power grid and those crippling labor costs at retail pumps.
Deadhead miles.
Yep. And now, in 2026, we are outsmarting the grid entirely. Between off-grid solar buffers, intelligent virtual power plants, and AI-dispatched mobile tankers, the necessity of ever visiting a traditional gas station has been functionally engineered out of the commercial supply chain.
And this raises an important question regarding modern corporate strategy.
Yeah.
Adopting these mobile and off-grid solutions allows massive companies to thread a very difficult needle right now.
How so?
They can hit their stringent ESG goals, tracking their carbon footprint with absolute digitized precision, while simultaneously slashing their operational budgets by eliminating labor waste and infrastructure delays.
Wow.
Environmental sustainability and raw operational efficiency have actually finally aligned.
That's incredible. Which leaves us with one incredibly wild thought to consider before we wrap up.
Let's hear it.
If mobile fueling, AI dispatching, and these decentralized off-grid pods become the absolute standard for how we power our transportation, what happens to the millions of acres of prime, highly trafficked real estate currently occupied by traditional corner gas stations?
Oh, man. That's a huge question.
Right. If the energy comes to us, will those massive retail footprints become the abandoned ghost towns of the late 2020s? Or are we looking at the ultimate commercial real estate redevelopment opportunity of the next decade?
The entire landscape of mobility is fundamentally shifting right beneath our tires.
It really is. Something for you to chew on.
Definitely.
That brings us to the end of today's deep dive. Thanks for exploring the sources with us and keep asking the big questions.